them what test you're doing, and I'm going to hand those out here in a second. And make sure you follow directions and teach them what you know about chemistry. Now what has happened with this erosion, it has pitted out the igneous rock and the metamorphic, and it kind of acts like, looks like a sponge now. You got all these little holes that the water can drain into. And what happens is the water drains through it, picks up minerals, the rain falls, and then the ground soaks it up through all these little holes that have been caused by erosion over the last few 100 million years. So the water seeps down into these little porous areas, and it goes into the mountain, and then it spits back out in little springs. The Hawksbill Creek, does everyone know where that is? Yeah. Did some of y'all middle schoolers go down there recently? Yeah. Well, that starts up here. That's where the Hawksbill starts. We're actually going to go where it comes out of the ground. At our first stop, we're going to test the water. Okay? So the water goes into the mountain, and then it comes back out. And it's actually a very short time period because of the porous nature of the igneous and metamorphic. So let's go ahead and start walking down. This is the very starting point. It's called the headwaters of the Hawksbill Creek, coming out of the mountain. So go ahead and start testing with your test. Make sure you read the directions carefully. Do exactly as they say. If you have any questions, ask. Please take your time and get to it.
What you're going to do is dip it in the water for 10 seconds, and when you're dipping it, move it back and forth.
Yeah, just leave it in there for 2 minutes, swirl it around a little bit.
Get it out, shake it, and then we're going to wait 20 seconds and match it with the
Granny, you can look.
Okay.
Go right next to the stream there.
You keep changing it, I'm crazy.
It's like not changing colors. It's like that one.
Take it out. Put it in 3 seconds, take it off. Woman in good colors.
There you go.
That means that. Yeah, mine is full. Maybe it's supposed to be like that.
Everyone got time? Watch.
I got it.
10:27.
10:27. So under the first column where it says time, make sure you write down 10:27. So for the very first one, sulfate, Deanna.
0.
So everyone needs to write down 0 for sulfate. Okay, let's talk about the units. All these units are in parts per million. So for phosphate, we had 0.1. That means there are 0.1 phosphate polyatomic ions for every million molecules. So is that a lot of phosphate or just a little tiny bit? Little tiny bit. Does that make sense? So if you had 1 part per million, that means you had 1 molecule for every million. So what do y'all think about our results? We got a high number for dissolved oxygen. Is that a good thing or a bad thing?
Good.
What do fish and other aquatic life need?
Oxygen.
Oxygen. So the higher it is, the better it is. Now oxygen comes from the air. If you want to dissolve a gas in a liquid, it has to be colder, right? So it's kind of cool this morning. It hadn't got hot yet. So the hotter it gets, the less dissolved oxygen you'll find. Okay? So we didn't get any iron, we didn't get any copper, no ammonium. We got a little tiny bit of phosphates. So it looks like so far there's no pollution coming right out of the mountain. So let's go ahead and go to the next spots. Be careful on the trail, it gets really rocky in the second half. Okay, let's head up. Don't get in the road.
Oh, please.
No, Bernie is not.
I'm going to take up the chemicals here in a second. So when I call for them, just bring them up. Okay, dissolved solids. Dissolved solids. And dissolved solids.
Okay, great. Gotcha. Perfect.